This is the highest the river will be this season, so there's this giant flush of particulate and nutrients that flows through the rivers.
In the early season, May or late April, the Alaskan Arctic is completely snow-covered, and with 24 hours of daylight and getting some warmer temperatures, thaw happens.
There's two rivers that we're mainly focused on, the Sagaviniartok River, or we call it the Sag, and the Kuparuk River, which is just probably 40 kilometers west of here.
You see it as first this kind of yellow trickle in the snow, and the color yellow is from all that soil organic matter that's being washed downstream as the ground is thawing and the snow is moving over land. And then basically the whole landscape just turns yellow. That's all that beautiful organic carbon that I love. Late May and June tend to be the sunniest days, so we don't have a lot of cloud cover or rain or snow. And so this pulse of all this organic carbon is coming out of the ground at just the right time when we have a lot of sun.
What we are especially interested in is studying how sunlight affects the carbon that's flowing in the rivers such as this one. There's a tremendous store of carbon in Arctic permafrost, nearly twice as much as there is in the atmosphere right now. So all of this carbon we're seeing melt from the permafrost and end up in rivers and lakes, and what's going to happen to that carbon is a really important question on a global scale.
Most of the waters are shallow. So in the early season, we've got sunlight, we've got shallow water, we've got all this organic carbon coming in, and the water's moving fast, so it's mixing all that up, and it's just continually getting exposed to sunlight. And those are factors that contribute to these high rates of this photochemical or sunlight-driven reaction that turns that yellow organic carbon into carbon dioxide.
If this carbon, which now is in an organic form, in a dissolved form, gets converted into carbon dioxide, it's going to end up in the atmosphere, where it can affect all sorts of things, namely reinforcing climate warming and additional melting of permafrost in the Arctic. So it's a reinforcing process.
The conventional understanding is that bacteria or biological reactions are mainly responsible for turning all that organic carbon into carbon dioxide. But what we discovered is that in the Arctic, the waters are cold and they don't have a lot of nutrients, and so the bacteria are very slow, and the sun doesn't care how cold it is as long as it's sunny out and sun is shining on the lakes and streams. That organic carbon will be turned into carbon dioxide. So relative to other places on Earth, that photochemical reaction is actually more important in the Arctic as a source of CO2 to the atmosphere, which was surprising to some.